Aven's going to talk about industrial construction to increase the speed and scale of building decarbonization, and he is a computational research scientist at LBNL. So with that, Aven, I'll let you take over, and please correct my enunciation of your name.
Thanks very much, Ted. Can you hear me okay?
Yes, we can. Thank you.
Great. And are you seeing the presenter view?
Yes, we are.
Great. Well, thank you for the introduction, and hi, everyone. My name is Aven Satre Meloy, is how you say that. And I'm a research scientist at the Berkeley Lab in the Building Technologies and Urban Systems Division. And today I'm going to talk, as Ted said, about industrializing construction and its role in increasing the speed and scale of building decarbonization. So just to give everyone a sense for where this presentation is headed, first I'll speak to some of the key buildings and construction sector challenges in the 21st century, and especially those that are relevant to the case of industrialized or advanced building construction. And then I'm going to next provide an introduction to the Department of Energy's Advanced Building Construction Initiative, which was an initiative that was launched in 2019 and has grown since then. I'm going to provide an overview of some of the research, development, and deployment efforts that have been underway through the ABC initiative. And then I wanted to end with a preview of some of the forthcoming market guidance for residential buildings that has been developed by the ABC initiative to really try and provide to highlight a case study of how some of the work that's been underway through the ABC initiative is going to hopefully lead to some market transformation and broader adoption of advanced building technologies in both renovation and construction markets. And then I'll end with some conclusions. So I wanted to start with a couple of the key buildings and construction sector challenges just to set the stage, and these will probably be familiar to folks, but I think that they're really useful to articulate in the context of advanced building construction. So the first is this decline in labor productivity that we've seen in the construction sector over the latter half of the 20th century. This is a graph from McKinsey & Company that shows labor productivity in terms of gross value added per hour worked across a number of the key economic sectors in the US economy. And as you can see, the orange line here is the construction sector, and it has mostly stayed stable. It increased a little bit from 1950 to 1970, but then decreased through the latter half of the 20th century. And that's in stark contrast to a number of these other economic sectors that have seen pretty large gains in labor productivity. So that's one key trend and challenge for construction in the United States. Thinking more globally, another challenge, and this one probably is familiar, some folks may have even heard this statistic before, the global building stock is expected to more than double in area by 2060. So over the next 35 years, the Global Alliance for Building and Construction estimates that around 2 trillion square feet of new and rebuilt buildings will be constructed in cities worldwide. That's the equivalent of adding the entire building footprint of New York City every 35 days for the next 35 years. So it's a pretty considerable challenge to meet that new construction demand. And then again, back looking specifically at the US market, annual retrofits in the US fall far short, both in quantity and the depth that's needed to meet the US's decarbonization goals. Really only about 2% of commercial building space and less than 1% of homes undergo energy improvements each year. These improvements are typically surface level. They rarely surpass 30% energy savings, so they really couldn't be considered deep energy retrofits. And I think most importantly, these comprehensive upgrades really don't appeal to consumers. They're either too costly compared to their perceived value, they're too slow, they're too burdensome, they lead to inconsistent performance, and there hasn't been a strong market signal of demand from consumers for these types of whole building deeper retrofits. So I'm just going to provide a bit more context for each of these challenges on the next slides. So first, regarding the construction industry's flagging progression over the 20th century, this is a couple of pictures of the Empire State Building and its construction in around 1931. And it was the tallest building in the world when it was built to 103 stories. It took about a year to build and around 7 million person hours. And if we fast forward 80 years to the construction of the Burj Khalifa, which is shown here in Dubai, this was in around 2010, it was 163 stories tall, so not quite twice as large as the Empire State Building, but almost. And it took about 6 times as long to build in terms of the years, and about 3 times as many person hours, 22 million to complete. And when it was finished, it became the tallest building in the world. And so this just sort of shows the lack of progress and efficiency in the construction sector over the 20th century and the early 21st century, whereas we've seen pretty strong changes in other economic sectors as a result of innovations in those sectors. Regarding the stat that I shared earlier about the growth of the building stock over the next 35 years, which is a considerable challenge for many reasons, but one that I think is more relevant to our field is the challenge of embodied carbon. And so for folks who aren't as familiar with embodied carbon, it refers to the carbon that is emitted through the production, construction, manufacturing, the demolition and disposal of buildings. And this pie chart shows the contribution of building materials and embodied carbon in those materials to overall global CO2 emissions. And I think this is an estimate from the Carbon Leadership Forum that the total from embodied carbon is around 11% of global emissions. And you can see that currently that is not as large as building operations. So the use of energy and electricity and the emissions that result from building operations. But I think importantly, as operational carbon decreases over the next 20 to 30 years, which we expect it will, because the grid is going to decarbonize, and increasingly we'll see buildings switching to electric fuels or using non-electric low carbon sources of energy. The operational phase of buildings will lead to fewer emissions, and building materials or embodied carbon will increasingly account for a larger share of emissions. And so I think it's important to keep that in mind, that this is a growing problem, and one that is really important to think about developing solutions for. And then finally, I mentioned the need for rapidly scaling whole building retrofits. This is from the World Green Building Council, and it's a pathway they developed for existing buildings to achieve net zero carbon. They find that current renovation rates, as I said, really are around 1% or less of the existing building stock each year. And when we're talking about really whole building, high performance retrofits, those are probably around 0.1% or less of the existing building stock each year. And that, of course, differs depending on which region you're looking at. But to achieve building sector decarbonization by 2050, these rates must increase to around 3% per year if we start in 2017, which we obviously haven't. This report came out, I think, in the end of 2016. And the longer we wait to start this effort, the higher those rates must increase. So that just indicates that, like in many cases for building or broader decarbonization, the longer we wait, the faster we have to change. Okay, so those are just a bit more context on some of these challenges, and I think that they really are relevant to advanced or industrialized construction, which I'm going to provide a brief overview of now. So the U.S. Department of Energy launched the Advanced Building Construction Initiative in 2019 with funding for R&D projects at the national laboratories and a couple of other institutions, academic institutions. And since then, over the past 3 years, the Advanced Building Construction Initiative has really built this kind of far-reaching, industry-facing work that tries to influence the uptake of ABC or industrialized solutions. So here's the mission statement for the ABC initiative. It works to integrate energy efficiency solutions into the construction sector to deliver affordable, appealing, resilient, and zero carbon new buildings and retrofits at scale. And I think the unique thing about the ABC initiative is that it includes both a research and development arm, which aims to innovate and validate building technologies and systems to achieve carbon neutrality for many different building types, but also includes a focus on market transformation. So thinking about how we can more broadly adopt these types of technologies in the construction sector. And the primary vehicle for this is the ABC Collaborative, which is an industry consortium led by the Rocky Mountain Institute and some other organizational partners that really focus on trying to deliver the research work of the ABC initiative that's happening at national labs and academic institutions to industry audiences in order to inform product design, to help aggregate demand for these types of innovations, to reduce the risks of deploying them, and then also to establish competitive business models for these new approaches. So I've been speaking really in the abstract about these approaches thus far, but I wanted to say a bit more clearly what we mean when we say advanced building construction. And really the ABC umbrella is a broad one, and ABC innovations can take many different forms. And this is just a look at some of the innovations that we are typically considering fall under the umbrella of advanced building construction. And you've been hearing me use these two phrases, advanced building construction and industrialized construction, and really they generally mean the same thing. I think industrialized construction is probably used more broadly across industry, whereas advanced building construction refers specifically to the Department of Energy's initiative. But both of these terms usually refer to a suite of technologies like those that you see on this slide. So things like drone mapping and laser 3D scanning to assess building facades, and then different types of modeling software and mixed reality even for installation. Then there's new methods of fabrication using 3D printing. There's offsite construction is kind of a large suite of approaches that are germane to ABC. And then one area of innovation that folks might be more familiar with is this exterior retrofit wall panel and the whole delivery process of factory assembly and site installation. And folks might be familiar with Energy Sprung, which is an initiative in Europe that has pioneered the use of these technologies. And so these as well fall under the broad umbrella of ADC. And so this is not an exhaustive list, but just gives folks a sense for the types of innovations that we're thinking of when we think about advanced building construction. Importantly, all of these innovations really share some key attributes. And these key attributes include superior energy performance and a low carbon footprint. They are often faster in terms of the construction and renovation process. They can be deployed more rapidly. Thinking things like factory-based construction can dramatically improve the time to installation. They are more affordable for both developers and consumers, and a lot of that affordability comes from the ability to reduce costs through these efficiency gains. And then finally, as I mentioned in the beginning of my presentation, the lack of consumer appeal for many of these products, well, it's a goal of the ABC initiative to make these products more appealing to owners and occupants and investors, simply because they work better, they're improved technology, and they improve occupants' experiences as well. So I'm just going to provide a brief overview of some of the key ABC RD&D efforts that have been underway to date. And again, this is not an exhaustive list, but should give folks some sense of the type of work that ABC has been cultivating over the past couple of years. And I think the kind of the most exciting area of focus for the Department of Energy has been funding to accelerate the development of these technologies in national laboratories, in academic institutions, and through private-public partnerships for different participating organizations. So here is just a look at some of the institutions, many institutions that are involved in these federally funded projects. And these projects are now moving into a second phase where they are actually developing. So phase one was prototyping these technologies, and then a select number of these organizations are moving forward with projects that are actually going to be demonstrated in real buildings with real occupants. And many of the targeted buildings are low income or affordable housing projects. So really delivering these benefits and testing the benefits of these innovations in affordable housing is a key focus area for the Department of Energy. And so this is one area of activity for the ABC initiative, is this federally funded activity. And that's really creating a lot of innovation and a lot of sharing of these ideas, both with industry, but as well as with the kind of the national laboratory community. Another arm of the ABC initiative is really focused on analytical work, and this is work that I've been a bit more closer to in my time. I didn't mention this earlier, but my role with the ABC initiative is coordinating the portfolio of analytical work that the ABC initiative has funded. And so this is one example of a project that we think can be really helpful for targeting the types of ABC innovations that are being developed and prototyped to different segments of the building stock. So what you're looking at here is the U.S. Building Stock Characterization Study, which was published by the National Renewable Energy Lab in partnership with Berkeley Lab and the Rocky Mountain Institute. And it has two parts, one focused on residential buildings and one focused on commercial buildings. And what this analysis and report do is provide really the first comprehensive assessment of the U.S. building stock in terms of the different characteristics and types of buildings and their energy use. And so what we've developed and made open access is these dashboards that we think can be really useful to a variety of stakeholders. And what you're looking at here is a map of county-wide average site end use intensity and the number of housing units across the United States. And this is just one visualization, but we have this interactive dashboard available that folks can click into on the link here if you're able to access these slides, which I think you should be. And you can go in and look at really granular regional and temporal results of energy consumption, but also building characteristics. So you could understand, for instance, the total number of buildings that are low-rise multifamily buildings with wood frame construction that heat with electricity or heat with natural gas or another fuel type. So there's incredibly granular characteristics available at the county level. And again, this is an incredibly comprehensive mapping of the existing building stock. And I think that is something that hopefully will be useful both to investors and researchers, but solution developers as well, to understand, okay, what's the target market for a given innovation that I'm working on? You know, how many buildings might benefit from this type of approach? So that's work that we've been doing. And one of the things that I wanted to close with here is just a preview of some forthcoming market guidance for industry that's focused on residential buildings. So what we've done is we've used these kind of baseline characteristics of the building stock, and we've looked at a variety of different upgrade performance levels for both new construction and retrofits to try and understand, can we say, you know, in different regions and different states, what types of buildings should receive which types of upgrades in order to be net zero ready or net zero compatible? And so this is a forthcoming report from the ABC Collaborative, and it's really about focused on accelerating deployment of ABC approaches, again, in both new construction and building retrofits in the residential building sector. And it combines this technical performance guidance with estimated installed cost targets to inform market decision making. And some of the objectives of the report are to identify, as I said, performance levels and priority market segments for different types of ABC solutions, to also develop cost guidance to ensure that the developers of these solutions are receiving signals to understand kind of what the market will bear out in terms of cost for these different types of technologies, in terms of their lifetime savings and other benefits, and then to highlight how factors like resilience, embodied carbon, and other non-energy benefits can really influence the value proposition. So this is just one figure from this forthcoming report, and I won't go into the details here, but it maps out across states which share of the building stock we assess in our analysis to determine or will receive these different levels of performance. And so what we're providing here to industry and to other researchers and policymakers is an assessment of the level of performance that's necessary to achieve net zero energy readiness in different segments of the building stock, and the costs at which those packages or performance levels should be targeted in order to be cost competitive. So I can't say much more about that now because I think I'm nearing the end of my time, but there's lots of interesting stuff happening within the ABC initiative, and we are working on both the innovation side and on the market deployment side, and there's lots of ways to get involved. There are a couple of different websites shown here, and of course, folks are also welcome to email us at the email there, or if they want to get in touch personally, there's my email as well. And with that, I will say thank you, and I'll take any questions that folks have.
Well, thank you very much. Yeah, I know back in 2007, I was involved with a project that had used SIP panels, so that was some of the way that they're trying to address some of that decarbonization, but I don't know that it really, how much it really impact carbon, but you got a better construction project out of it. One question I had was, and if as I'm talking here, if you have a question, audience, you want to just submit one, we can probably take one or two questions and then move on. But HVAC pods was one of the things listed on one of your slides. Can you explain what's all involved with HVAC pod, or what you think it might be? There you go.
Yeah, thank you. Thanks. I elaborate on that one. So these are kind of combined mechanical system pods that include high performance heat pumps and heat pump water heaters that can really kind of be modularly developed and installed in buildings. I think they're more commonly seen as a solution for multifamily buildings, but it's kind of a packaged HVAC solution that can really speed up the installation process and make installation more straightforward as well, which will hopefully lead to cost declines. So that's a general overview of that solution or that technology.
All right. Well, maybe what we'll do is we'll just stop it right here then. Thank you very much, Aven, for your time and for your presentation. We really appreciate it. If there's more questions, we'll certainly forward them over to you and connect people with you to get them answered. But thanks again.